I knew I wanted to do something technical.
I knew I wanted to play with robots. I'm not just a technical person, I'm also a person that's interested in art.
I began taking classes in the bio department, and then when I took the Intro to Computer Science course, Com 110, which was a programming and problem-solving course, I got really interested in it. And I guess the field I'm more interested in now is sort of the data structures, data mining side of computer science.
I actually came here for the Japanese program, to be completely honest. CS has always been an interest of mine, but it was never so much of a passion. It was never really something I wanted to study. And I started dealing with robotics, and I started dealing with the more in-depth studying. We didn't really just create, small programs to print out "Hello World" on the screen. We actually started, writing programs that would deal with complex data structures, really in-depth ways of handling information that you would actually use in the real world.
Sorting, different problem-solving homework assignments and things like that. And being able to do that and being able to work in groups and things like that made me even more interested. And that's why I like computer science, because it gives me a chance to help people and it gives me a chance to solve problems.
It's one of the more practical majors that you can get out of a liberal arts education, in my opinion.
You're in class learning different programming. It's not like you're sitting in class listening to a teacher. It's your hands-on. I didn't think I would learn so much so quickly, and the computer science department just really showed how it can be achievable if you work hard at it.
It actually happened the first day of class when we're sitting there, my teacher's describing it's an intro class, nobody needed experience for it, so she's kind of describing the stuff you do, and the first thing she said was, how many of you, when you're sitting at the computer using Google, are wondering, wait, how does that work? Or, you're on MapQuest and wondering, how can they possibly do that? She's like, this class is gonna, start to answer some of those questions, and I was just like, this is what I want to do.
Bringing it in and putting it in there, and then you just click it.
After if you wish. Well,
We probably engage the students in undergraduate research more than most schools.
I'm doing a senior honors thesis, which involves modifying Carnegie Mellon's open source speech recognition system to develop a keyword spotting system. So the idea of a keyword spotting system is to be able to pick out these individual keywords from unconstrained or free speech. I initially started designing this system to be used in conjunction with my senior project for the Ammerman Center for Arts and Technology. And that's an installation art piece that combines my interest in photography and environmentalism and computer science.
I'm combining both film and computer science in a video installation. That's what I was looking for from the beginning, just being able to combine both computer science and the arts. We went to an archaeological site, and afterwards we created a VR environment, so a 3D environment, to explore the archaeological site, how it had been in the past, how it is now in the present. Me and my professor actually went out to the site, the archaeological site, and filmed it, and then I used that footage to recreate it. It was really mixing together different subjects in one project. It was good.
I have been working on a 4-rotor aerial robot, which is actually sitting on the table right next to me. My research has been to create autonomous flight with this guy. We wanted something that we knew would work aerodynamically and we knew was a proven design So we bought a commercial kit for that reason, but what we're doing differently is that we've ripped out all of its brains and we're programming our own. And we're in fact one of the only groups, myself and Dr. Parker, are one of the only groups using the architecture that we're using for the brains.
Right now I'm working on prey and predator project, and we're gonna see predator running, and it's gonna be walking around looking for a prey, and the prey is supposed to shine a light. Like whenever it sees a bright light, it thinks that that object is the prey, so it tries to get as close as possible. And this is all before it started to learn by itself, and we need to make a couple modifications with the light sensors before it can really go after learning.
I think one of the unique things about us at this college is our undergraduate research, and we really help the students get involved in undergraduate research. This is research at a significant level. We've had several students that worked with us have gotten publications. For example, even myself, over the last 5 years, I've had over 20 publications at peer-reviewed international conferences with students from Connecticut College.
In other undergrad programs, I think it's even hard to see the professor's face. Like, I have people in other computer science programs, in other colleges, in other universities, and they don't see the professor's face, whereas whenever I have a problem, whenever I need to ask a question, I can directly talk to my professor and get a good answer for it. And I think that's the good part of this school. That's a great opportunity for us.
But here at Con, your name, your person, and your personality. So I have to say that teachers care about you maybe so more than if you were at a larger school, and that's why I came here.
You get to meet your professors as people, not just as people in a classroom, which is a lot of fun.
That's kind of what computer science is. It doesn't exist in its own little realm, but it aids everyone else.